Hello, ladies and gentlemen. Thank you for visiting us today. I would like to introduce you our innovative technology for corrosion test panel measurements. My name is Ralf-Jan Böhrheide, and I am co-founder of ORONTEC. I have divided this session into two parts. A first part where you can get all necessary information within 5 minutes, and a second part where you can learn more about the details behind our technology. So, if you are short on time, you can just listen to the first 5 minutes and continue with the other part later. Additional information is always available on our website. So, let me show you who we are and what we have done to make life easier for people who work with corrosion testing. Allow me to introduce ORONTEC first. We are a German technology company with focus on solutions for the paint industry. We work in 3 fields. First, equipment. Systems for color measurement, especially in liquid, to reduce the testing time in production up to 99%. We also supply laboratory automation solutions, such as our surface scanner, for replacing manual measurements with automated measurements. Second, software. Our customers get modern software solutions to help them automate their workflows, generate reliable data, and integrate hardware according to the Industry 4.0 concept. Third, consulting. Using methods of Lean Six Sigma and others, we carry out process analysis and optimization. Why did we invent the Q-Chain SuMo technology? Well, if you look at the state-of-the-art methods consisting of scratching, stressing, and scraping, you see that scraping and measurement are manual tasks which are boring and imprecise. The deficits are obvious. The destructiveness of the method makes it impossible to reduce a sample. The results have a high user influence, and it is simply a waste of time and money. What is the solution? Well, we designed a compact piece of equipment called Q-Chain SuMo. This technology compensates the deficits of the common corrosion test panel measurement. It is a small, compact device which fits on a lab bench, and it is capable to handle 20 panels for automatic measurements. The panels are stacked in handy magazines which help to store the panels and easily move them in packs of 20 in the laboratory. The sensor is based on photometry. This method is extremely precise and robust for a large variety of materials. The software which comes with the equipment is intuitive and easy to use. Reporting is generated automatically and always connected with a picture of the sample. The evaluation is flexible and meets all international standards. The sensor can detect delamination and rust on a panel, but doesn't damage the surface because it is touchless. That's why the method is non-destructive and allows a reuse of panels, for example, for the measurement and evaluation of sample series. Q-Chain SuMo is ready to connect to our Process AI framework, a solution for a workflow measurement in laboratories. So, what is the Process AI? Q-Chain Process AI is a workflow-based software solution for any kind of laboratory processes. It connects all steps of a testing process in a web interface and makes it possible to combine automatic measurement devices as well as manual processes. Additionally, it can connect to other existing data sources like ERP systems, LIMS systems, and even Excel files, databases, or just text files. However, it uses a central database to collect all relevant data and makes it possible to use digital and traceable data over the whole process. This is the key for understanding and evaluating data and discover hidden correlations of different data. The solution is scalable. It can consist of just a few steps and grow to more complex processes. It is flexible because it can be adjusted to new workflow designs at any time. And, of course, it is easy to use. As a matter of fact, because it is working with an internet browser. What is the value? Users don't have to use different applications to manage their work. Data is accessible exactly when it is generated. The implementation is easy and starts with a very simple workflow. Time of giant software projects is over. Here is a short summary of part 1 of this presentation. Q-Chain SuMo is an automation solution in a compact equipment, which replaces boring and expensive work. The non-destructive and precise measurement method enables the reuse of panels and makes test results more objective. Data is digitalized and available for further digital analysis. The system is ready for the integration into the revolutionary Process AI framework for workflow automation and integration of further testing equipment. Thank you for your attention until this point. If you are interested in more details, stay with me for another 10 minutes. Are you still interested? Great! I will explain you more details about the measurement principle, the design of the machine, and the most important software features. This takes another 10 minutes of time. The measurement principle of the sensor, which is built into the SuMo, is based on photometry. The sensor itself is an active sensor which uses a laser pulse to heat up the surface of the panel, or more precisely, the coating layer. The coated surface is absorbing the laser radiation and transforms it into a three-dimensional heat wave. The temperature of this heat wave is measured by an integrated heat sensor. The measurement signal consists of a temperature against time plot. As the laser is pulsed, the plot shows one pulse, the temperature increases during the time when the laser is on and decreases when it is off. This temperature plot is characteristic for the physical properties of the coated layer and, for this specific purpose, it can be used to detect changes in the layer generated from delamination and rust. How does the Q-Chain SuMo work? The sensor, number 5, is mounted on an XY axis system, and its distance to the panel is adjusted by a Z-axis. The input magazine, number 1, takes 20 panels, as well as the output magazine. The magazines are mobile, which makes it possible to use them outside of the machine for loading and unloading the panels and use them as a buffer for panel series. A conveyor belt, number 2, pulls the panels from the input magazine to the measurement position, number 8, where the sensor carries out the measurements. A camera, number 6, takes a picture of the panel, and it also detects a QR code on the panel. After the measurement, the conveyor belt pushes the panel into the output magazine, number 3. The size of the equipment is 770 millimeters in height, 480 millimeters in depth, and 620 millimeters in width. Underneath the measurement area, all electronics are integrated. The machine needs only electrical power and is controlled by a conventional Windows PC. The setup is designed for standard panel sizes with a certain variance. When it comes to the reports of the measurements, the results are shown in a picture highlighting delamination in yellow and rust in red. Stripes with green color show areas with normal adhesion of the coating on the substrate. All measurement data is saved in a database. Reports are generated in an MS Excel format. Here is an example of a report according to the ISO 4628-8 standard, which consists of the colorized picture, the evaluation, average width with delamination, and the data of each measured line. The picture is part of the Excel report. Here is an example of a scanned area with a blister under the coating layer. The picture on the left side shows a visual impression of the blisters, but the colorized evaluation of the measured data show more blisters than the human eye or a camera can see. This example is a panel from a powder coating application, and we made this test to see how much a pure visual inspection can detect delamination of coating layers. There have been attempts to just use visual inspection on unscraped panels, but this example shows the limits of such an approach. Due to the texture on the surface, it wouldn't be possible to analyze the surface exactly enough. The red and yellow areas show that the delamination and rust is broader than what the human eye or a camera would be able to detect. On the scraped panel, we were able to prove that the original interpretation was correct. So we were able to prove that the measurement principle we use in the SuMo is the most reliable and most precise way to detect delamination and rust on unscraped panels in a high resolution. Not all corrosion tests are carried out on standard panels. In case of larger panels and/or flexible panel sizes, we designed a study which uses a different panel handling system. The panels are put into cassettes, which are pushed into a stack system as shown in the picture on the top, number 1. This setup can potentially take more than 20 panels, but will need more space and will be placed on the floor. Another possibility is the measurement of 3D parts. The Q-Chain SuMo 3D study is a modified standard machine from ORONTEC, where the sensor is moved on a multi-axis system and the part itself is fixed in the middle of the machine. This setup needs more space, but it can be used for a large variety of parts. Both systems would be individual setups which would require higher investment budgets than the standard Q-Chain SuMo. We thought that it is not enough to just provide a measurement tool. It is a tool and not yet a solution. To make it a solution, it needs a framework which makes it possible to be integrated into the environment of a customer process. One of the product lines of ORONTEC is the process automation solution Q-Chain Process AI, which automizes workflows. A lot of work in laboratories is routine work, which uses the same measurement instruments, the same instructions, and even the same reports. In an environment of so much standard work, automation is just a logical next step. But let's start with a simple workflow. The measurement of, say, a corrosion panel is started and the machine loads it and conveys it to the measurement position. After reading the QR code, this code is matched to an existing so-called measurement job, which tells the machine what to do. After the measurement is carried out, the data is saved and a report is generated automatically while the panel is pushed back into the magazine in parallel. So far, so good. If we go to a higher level, we may think about what is necessary to feed the database with measurement jobs. We need a software solution which connects a standard measurement grid, which we call template, with a specific QR code and additional information, such as the used material or a test ID or a customer number. Generating measurement jobs is also a standard process, and you can see that it uses the same database as the standard process of the measurement itself. The operator selects an existing template, connects it with parameters, and generates a QR code as an identifier of the sample. But this procedure is also a standard procedure of any other panel testing process. In a first step, each of the workflows can be used by itself. This is a so-called microservice. But you can imagine that all these workflows can be combined to a larger process, which in the end shows a complete laboratory workflow process as shown in the next slide. What has started as a small microservice can end up in a complete workflow management for corrosion testing, which is not limited to collecting data only from the SuMo, but also parameters of the cycles of the corrosion cabinet or temperature curves of a curing oven. The flexibility of the Process AI framework makes it possible to integrate data from existing applications, such as ERP, LIMS, or other data sources, use interfaces to automatically pull data from the equipment or instrument, provide a user interface for manual data entries, for example, if the scribing is done manually. The user of this software solution is working along the process diagram, in contradiction to several separated programs. A step in the workflow may open a specific software, but once the application is closed, the user continues in the process diagram. If decisions are made in the workflow, these decisions can be automated by Process AI with underlying machine learning algorithms. The application is 100% web-based and easy to use. It can be expanded to other processes due to its flexible design. To summarize the possibilities of Q-Chain SuMo, it is an automation solution. Due to the non-destructive nature of the test, it allows a reuse of test panels and no scraping of the panel is necessary. The automation and the sensor result in much better R&R values than the manual process. As an additional feature, it is possible to use the method for scribed test panels before the corrosion cabinet in order to detect delaminated areas caused by the scribing process itself. It is ready to use for the Process AI framework, and it is a tool to digitalize test results. Thank you for your attention and your time. I look forward to hearing from you. Please use our website for contacting us if you have any further questions.